All right, we are starting chapter 7. I'm going to warn you that this chapter might be a little bit frustrating and sometimes confusing. I would just suggest to try your best, and we will get through it together. I promise. I'm here to help you, and I know this one is challenging, and I know we are not together in class to get all the confusion and everything answered. So there will definitely be some grace given for this chapter, for this test. Okay, so we're going back to trig. Okay, only 5 sections in chapter 7 we're going to do. So 7.1, basic trigonometric identities. So these are called trigonometric expressions. So something with trig, that is an expression. That is a trigonometric expression. Right? That's all it is. An identity, I'll move it over so that I'm not in a shadow. There you go. An identity is when two expressions are equal for all values. Super important that all values. An identity with trig expressions is a trigonometric identity. So pretty much when we say one expression equals another expression, totally made that up. There's no way those are equal, but you get the idea. Okay. If you can show an example of a value that is false in the trigonometric identity, that is a counterexample, and that instantly proves that the equation or the identity is not true. It is not an identity. Okay, so it only takes one counterexample. Okay, so here's our first problem. It says, prove that sine of x cosine of x equals tangent of x is not a trig identity by producing a counterexample. So pretty much what we're going to do is plug some numbers in here to find out, to find one that's not going to work. Okay, we could think about our unit circle and think about what tangent is at different points to think about what multiply won't make it equal. Usually when we work with trig and as we move into calculus, trig will be in radians. We will have some degrees throughout this, but usually when we plug in numbers and try things out, they're going to be in radians. Be careful with what your calculator's mode is set in if you're going to use your calculator for some of these spots. So I'll squeeze my calculator in here. I'm going to make sure my mode is on radians. It was not. Okay, so I might even just start going around my triangle at certain amounts. So I might start with trying x equals pi over 6, 30 degrees. See if that works. So sine of pi over 6, cosine of pi over 6 equals tangent of pi over 6. We're going to put a question mark here because that's what we're trying to figure out. Okay, so I could just type this into my calculator because I put it into the right mode. Okay, so that equals 0.43806 approximately. Let's see if tangent equals that. Oh, it didn't. Tangent equaled 0.57735, so we know these are not equal. Okay, we could have even used another number. The other nice thing about this is you could have your unit circle out and just look quickly what was sine at pi over 6. That was some number times cosine of pi over 6, multiply them together. Does that equal tan of pi over 6? And you wouldn't even have to use the decimals on our calculator. Okay. All right. Proving an equation is an identity takes more work because you must show the equality holds or works for all values. Okay. So we're going to talk about a handful of identities. Some of them we'll look at the proofs. Some of them I will refer you to the page number if you want to take a look at them. But these are identities that we've found to be true. So first one, reciprocal identity. Trig functions can be defined from the unit circle. So here's our unit circle. We know that this is our x unit, our y unit, 1. So we know that sine is going to be y over 1, or 1. Cosine, x over 1. Tangent, y over x. Okay. We know those things from our standard unit circle. So, like I said, if we know that sine of an angle is y over 1, or y, and cosecant, the flip of this, is 1 over y. So cosecant equals 1 over sine, or, so we're going to plug in, we know that y equals sine of theta. So if we plug in sine of theta where y is, we will get cosecant of theta equals 1 over sine, because y equals sine. So pretty much in place of y here, we're plugging this in. That's where we get this. Or we could flip it around using our multiplying and say that sine of theta equals 1 over cosecant of theta. Okay, these are identities we know to be true because of the unit circle. Right. So here's a list of them. Probably want to pause and write them down. We know that sine equals 1 over cosecant of theta, and all the way down. Okay. All right. Quotient identities from the unit circle tell us that sine over cosine, which is y over x, equals tangent. So therefore, sine of theta over cosine of theta equals tangent, or cosine over sine equals cotangent. All of these identities are going to continue to come up throughout the chapter. Okay, so you will probably be flipping back if you don't remember them, or if you want to write all the identities down on one page, one note card as we compile them. That could be helpful as well, or putting a sticky note on these pages so you can flip back to them easily. All right. Okay, so we have the next identity we have is the Pythagorean identity. Since our triangles in the unit circle are right triangles, we can use the Pythagorean theorem. So we know that a squared plus b squared equals c squared. Well, on our triangle, we could say that y squared plus x squared equals 1 squared. Or we could substitute those for sine squared plus cosine squared equals 1. Okay. Other identities can be derived from the Pythagorean identity. If you want to take a look closer, you can look at the top of page 423, but these are other Pythagorean identities, and I guess I should have put a box around them. So I will add it right now. So you can see that these are important, and they're identities that'll come up. A lot of these identities that we see in this chapter are going to pop back up next year. Smiley face. Okay, example. Use the given information to find the trig values. If secant of theta equals 3/2, then find cosine of theta. Okay, well, let's peek back and see how secant and cosine relate to each other. Okay, so we know that cosine of theta equals 1 over secant of theta. We can plug 3/2 in where secant is, so we could say cosine of theta equals 1 over 3/2. Okay, or my little math I like to do, 1 divided by 3/2. We could say 1 times 2/3, because we just flip them. So we'll have that cosine of theta equals 2/3. So there you go, there's your answer. Push that up for you. Okay, if cosecant of theta equals 4/3, find tangent of theta. Okay, so if we take a look at all of our identities, any of the things we've shown, do any of them have a cosecant and a tangent? Well, the reciprocal identities don't. We know cosecant and tangent don't have anything to do with each other. The quotient identities didn't either. Okay. The only one that I had was right here, the Pythagorean identity. Okay. So if we can put 4/3 in where cosecant squared is, we could find out what cotangent is, and then once we know cotangent, we could probably figure out what tangent is. All right, so I'm going to use this up here. 1 plus cotangent squared of theta equals cosecant squared of theta. Okay, so this is our cosecant, and we need to square it. That's a 3. Okay, so 1 plus cotangent squared of theta equals 16/9. Okay, let's get, now we're solving for cotangent. So I have cotangent squared of theta equals 16/9 minus 1, or 9/9, so that'll be 7/9. Okay. I'm going to square root both sides. When I square root, I need to remember to add a plus or minus. So we'll say that cotangent of theta equals plus or minus the square root of 7/9. Fabulous. But we actually want to know what, let's reduce this, or we could say that it's equal to plus or minus the square root of 7/3, right? Because we know the square root of 9 is 3. Okay, so now we want this to be tangent. So we know that tangent of theta equals 1 over cotangent of theta. That's one of our identities. So we are going to put this right here. So we'll say tangent of theta equals 1 over plus or minus square root of 7/3. Okay, we know, oh, look at that, I have so much room. Okay. We know when we have 1 over, we just flip it. 3 over square root of 7. We can't have a square root of 7 in the bottom, So we need to multiply by root 7 over root 7. So tangent of theta is going to equal plus or minus 3 square root of 7 over 7. Done. Okay, next page. I guess I could box these up or circle them since I found my answers. All right, the next thing we're going to look at is symmetry identities. I will be honest, this is the part that probably confused me the most about this chapter. This section. If you want to look on page 424, it explains these identities more in depth. But here's kind of the rules for them, and we'll kind of work through them as we go, okay? All right, so please remember, this is something I kind of finally wrapped my head around, is that our goal is to write an expression that makes whatever number we are given in terms of 180, 360, pi, or 2 pi. Because we're, in a sense, reducing that number to fit into a quadrant that we know, okay? All right, so there are 4 different possible scenarios. Case 1 is when we can turn the number into some number plus a multiple of 360. Okay. Works on both of them. All right. The second scenario is when you can take 180 and you can take some number plus 180 times an odd number, because it can't end up being 360. So an odd multiple of 180. Okay. Then the next one is when you can take, this one is just a flip of the first one. So when you can take a multiple of 360 and subtract some number from it. And this one is when you can take a multiple of 180. Okay, so this would be an odd number, and subtract some number from it. We'll work through some problems together, okay? It's a little hard to get, it's finally clicking in my head, but you're going to want to look at these up here. So the directions say, express each value as a trig function of an angle in quadrant 1. Do this, okay? All right, problem number 1 says sine of 600. So we want to have our final answer is going to be sine of something. So we're going to look at this 600 and look at all of these cases and say, so if we look at 600 or we look at multiples, so honestly, maybe something random I just thought of. Maybe I would write down even my multiples of 180 to see what number it gets closest to. So I have 180, 360, 540, okay, 720, 900, 1080. Okay, let's see if my random thought works. Okay, so let's see. 540 plus 64. Okay, perfect. Okay, so 600, if we look at these numbers, which number is 600 closest to? I would say probably 540, okay? So this would be K as 1, 2, no, ignore me. Okay, all right, 540. So 600 is going to equal 540 plus 60 to get back to 540. All right? Well, 540, if we want to get these in terms of 180 or 360, 540 is 180 times 3 plus 60. Okay. So if we look up here, are any of our equations 180 times an odd number plus something? Well, that would be case 2. All right. So on case 2, this is what we're looking at. So that means that our A is going to be this number. So on case 2, our final answer is just negative sine of A. And that's your final answer. All right. So pretty much we're looking to manipulate this number to fit into one of these things. Okay, using these multiples of something. Okay, let's try it again. I like my numbers I wrote down, so I'm going to keep them even though they're a little messy. Okay. Oh, bananas. Okay, let's write down the pies. So pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. All right, so this one's in terms of pi. So we need to find out what 19 pi over 4 is equal to. So let's do 19 divided by 4 is 4.75. So we're probably closest to 5 pi. Okay. So I'm just going to write a note over here. So we're looking at 5 pi. 5 pi, though, we need to change in terms of a 4 so that we know. So it would be 20 pi over 4. So sweet. 20 pi over 4. In order to make that equal to that, we need to subtract a pi over 4. And now we have our numbers equal. Woohoo! Okay. So the next thing I'm going to look at is how can we need to look at which one of these would it be like. Well, 5 pi over 5 pi is an is going to be an odd multiple. Okay. And then we're subtracting, so it must be like case 4. Right? So then this is going to be our A right here. So what we're going to do is we just do sine of A. Let me back myself up a second. I don't know if I said this. These symmetry identities, what they help us do is find the sign of an answer, because we don't know if it's going to be positive or negative or how it's going to be impacted. So these symmetry identities help us reduce these as much as possible, because then if we use our unit circle, we could find what sine of pi over 4 is, and that would give us our answer. On the one before, it's important that we use our symmetry identities because we need to take whatever the sign of 60 is and make it negative, and that's going to give us this value, because remember our unit circle, how it works. Okay, I'm going to make a note up here on these. So actually, I'm going to make a note in the middle of this thing right here. So case 1 and 3 are when we have even numbers, and case 2 and 4 is when we have, well, even, let's say multiples. I don't like numbers, multiples. Okay, so right here we had an odd multiple, so we chose either case 2 or 4, and in this situation we ended up choosing this one ended up being case 2. We have an odd multiple, so this one ended up being case 4. Okay, well, let's look at these last two and see what they end up being. Right? All right, so negative 410. Okay. These also work in the negative direction. So which one of these numbers is 410 closest to? Even though it's negative, probably 360. So we need negative 410 to equal negative 360. Looks like plus negative 50. Okay, or they did minus, but that's okay, either one. Okay. Because this is 360, that's going to be an even multiple, okay, or 360. So this one, we had a minus here, so it looks like we're going to be looking at, cosine. Okay, we're over here on these ones. So same thing, we're looking at the 360s, and we had a minus, so we need to look at this one. So we're looking at case 3 on this one. I'll write it just in case you want to look at that later. Case 3, okay. So this number right here is going to be your A. Your A is always going to be just a number. It's not going to be positive or negative. So this negative isn't actually attached to that. It's attached to this sign right here. So we're going to have cosine because it needs to match. Okay. Cosine of 50. And we need to look at case 3. And there was no negative. So our answer is just cosine of 50. If you're confused and you need me to walk you through it, please let me know. I'm happy to walk through a problem with you, okay? All right. We don't have any tangents above, but we can do this similarly with tangent. So the first thing we're going to do is look at 37 pi over 6, and let's figure out what this is going to be first. So let's do 37 divided by 6 and figure out what that is. That's about 6.1. So we're going to go 37 pi over 6 equals something a little bit more than 6, which means this fraction needs to be 6, so we know that'll be 36 pi over 6 equals 6, right? So we're looking at 6 pi. Okay. To get to 37, we need to add a pi over 6. So now we need to look above at, this is an even number, and this is an adding. So an even and an adding means that we're taking a look at case 1, which is just going to be cosine of a number. So I'm going to write for you your future knowledge right there. This is going to be our A. So we're going to have cosine of pi over 6. Oh my goodness gracious. I abandoned what we were looking at. Okay. Yes, it's going to be case 1. Okay. Now I need an eraser. Okay. So actually, we are looking at I'm using pen. Thank you. My husband just threw an eraser to me. It was so sweet. Okay. Okay. I did this problem wrong. So let's see what I have here. I thought I have Post-it somewhere. Let's see if I can find them really quick. I probably can't. Ah, here they are. Okay, just kidding. We will need some of that information. Okay. So the first thing they did was like what we did, where we did the this part is right. Okay, we did that right. The problem is that now we though need to put it, because it was tangent, we need to say we could say tan of pi over 6, or we can rewrite it as sine of pi over 6 over cosine of pi over 6. Okay. We need to look above as well. Doing it again. Okay, what we did works, but we need to put it into this format. Because, okay, if you notice above that the signs aren't always the same depending on what happens, okay? So we need to make sure they're in the right format for the signs, okay? Because that's the point of this whole thing. So the first thing we're going to do is we're going to look at sine of an even number adding something. So when we have sine of an even number and we add something, we just have sine. So this is just going to be sine of pi over 6. Okay, now we need to look at our cosine. Cosine of an even number when we add. Even number add, so that's just cosine. In this problem, my skipping worked, but it won't always work. So please be aware and be careful. Okay. So now I have sine of pi over 6 over cosine of pi over 6, which then equals, we could just simplify it to tan of pi over 6, which is what I assumed, but we have to be careful. Okay. So that would be the answer. We just have to be careful because, for example, if this was if we were subtracting a pi over 6, for example, our signs would be different. Okay, so this is what we got in the end, but we just need to be careful on the way there. Okay, take those away. Let's fold under my note. That's redeeming my mistake. Okay, there we go. Okay, next one is the opposite angle identity. This is like case 3. I got rid of my case 1 for you. Okay. Opposite angle identity is case 3. When k equals 0, the negative sign is just going to flip the sign out front, and the negative sign is going to get rid of the sign. Okay? So it's just random identity for you. Okay, last problem says simplify. All right, so what we're going to do is we're going to take all of our identity knowledge that we can, and when we simplify, the goal of our simplifying is to get back to one of the basic trigonometric identities. So the simple ones from the beginning. So getting back to either sine, cosine, tangent, cosecant, secant, cotangent. Okay, so when it wants you to simplify something like this, our goal is to get back to the so if it says to simplify, we want to get back to one of the 6 basic trig identities. So these are the ones we've been working with. Okay. All right. So if we take a look here, what do we notice is the same in both of them? I see a sine, so I'm going to reverse Pythagorean theorem. Okay, you might have to flip back and forth now. 1 plus cotangent squared of x is another one of our trig identities. So the only ones we have so far that deal with squareds are our Pythagorean theorem ones. We know that 1 plus cotangent squared of theta is equal to cosecant squared. Okay. Okay. Cosecant squared, I'll make a note for you. This is a Pythagorean. Okay. Cosecant squared is equal to 1 over sine squared. Now we can simplify. A sine in the top, squared here. So we have left 1 over sine of x, which is just equal to cosecant of x. Okay. This is not simplified, even though there's only one trig identity, we still have this division. So this is our final answer. So this messy, lovely thing right here is actually equal to cosecant of x. Okay? These are kind of fun. Playing around, manipulating, they sometimes get frustrating. All right, homework assignment. I cut it down, okay? So your homework assignment, I know it might seem like a lot, but this is less than it was supposed to be. Page 427, number 19 to 53 odds. Okay. All right. Let me know if you have any questions. We can hop on and chat and run through some problems if needed. Okay. Have a great week.